Hello, hello, welcome. So we've got two really disgusting equations to solve. The good news is, though, it kind of factored already for us. So I see an x minus 5. I see an x plus 1. Is x minus 5 times x plus 1 this quadratic here? Negative 5x plus 1x is negative 4x. Negative 5 times positive 1 is negative 5. Yay! 99 times out of 100, that's what happens. So check it, like don't just blind go with it, but expect it. So this bottom here is really x minus 5 times x plus 1. And my other two denominators have one piece of that. So the common denominator is x minus 5 times x plus 1. And we have a lovely equation, so we're going to multiply both sides, which will end up being every fraction by that common denominator. Now, brackets, same as parentheses. I'm just putting them in so it looks a little different. So on the left side, at least, the x minus 5s cancel out. So I've got 3x onto x plus 1. Now, when I'm doing this cancellation step, I don't like to multiply the tops, just in case there's a minus somewhere, just like we did on the subtraction one, just to keep things safe. All right. Now, x minus 5 times x plus 1, that all gets multiplied here, and the x plus 1 will cancel. So we have 2 times x minus 5 plus, everything is going to cancel here. So we just have the top left over, the 2x squared plus 40. Poof, fraction's gone. One caveat though, restricted values, we're dealing with an equation. So x cannot be 5 and it cannot be negative 1. If we get either of those two answers at the end, we chuck them out. I'm sure we'll get one of them, we always do. I'll show you what happens if you plug it back in, because that's the other way to tell. If you forget to write them down at the beginning, then at the end it's the, oh, check to make sure they work, that they don't give you bad math. All right, so let's start cleaning this up. 3x squared plus 3x equals 2x minus 10 plus 2x squared plus 40. I'm going to go ahead and move some of these. 2x squared and the 2x. Actually got rid of quite a bit. So it's x squared plus x. And then on this other side, I have the minus 10 plus 40 is going to give me a positive 30. And now I can move the 30 over. X squared plus x minus 30 equals 0. So it's going to factor 5 and 6. We want a positive x, so we make the bigger one positive, the smaller one negative. So our potential solutions are x equals 5 and x equals negative 6. But wait. Remember I said one of these was going to be the screw up. Here it is. X can't be 5. I just got 5. This happened because we multiplied. Essentially, if x was 5, what we did was we multiplied by 0. So of course everything's equal. We got 0 equals 0 essentially. But if we actually put it back in there, we're going to get 3 times 5 over 5 minus 5. Uh-oh. So this is what the check step would look like. So we get 15 over 0. No. Throw it out. -6 is not a restricted value, so you can plug it into check, but all I would do is just check it in the denominators. Like actually plugging in, working it all out, you can, but you can also just type it on the calculator with a lot of parentheses, which is not a bad thing to get used to, because when you try to type these things into graph, lots of parentheses. Every complex fraction has parentheses on the top, parentheses around the bottom. Just FYI for next week. All right, so one down is just solving a quadratic and double checking our answers. And that is actually going to be the end result when we do some of the exponential and logarithmic equations. We're going to end up with some quadratics, and then we have to check the results, particularly in log equations. All right, and then I copied this ugly mess. And I say that because the denominators are very different, and there's just a number hanging out there with no denominator. So we will see what we get. It may be something ugly, who knows? But our common denominator is x minus 3 and 2x minus 1. There's nothing to factor there, it's just each of those. So I need to see them both. So that means, let's just move that over so I have some more room. Move that. There we go. All right. So this denominator is gone, leaving us with 3 onto x minus 3. This denominator is gone, leaving us with x onto 2x minus 1 plus, and then we got that. I'm going to go ahead and FOIL those two together, so we get a 2x squared minus 1x minus 6x will be minus 7x's and plus 3. All right, now we got to clean it up, but this is clearly a quadratic. So we're eventually going to have to get everything on one side, and then we can see if it factors. It probably does, or we can use the quadratic formula. So 2x squareds minus x plus 4x squareds minus 14x's plus 6 is 3x's minus 9. All right, there's so much going on here. I'm going to combine like terms, then I'll move the stuff over. So 2x squared plus 4x squared is a whopping 6x squared. Then a negative x minus 14x is minus 15x's plus 6 equals 3x minus 9. Oh, well, I'll move stuff over and then we'll do the, oh. So we have 6x squared minus 18x's plus 15 equal to 0. So, oh, now that it's equal to 0, and you may have noticed it before, what do they all have in common? What are they all divisible by? 3. And since this is an equation, I'm just going to divide both sides by 3, which means divide everything here by 3 and the 0 by 3. And now we have a much smaller, nicer to work with quadratic. So now it's only 2x squared minus 6x plus 5 equals 0. 2 times 5 is 10. You know, I don't think that factors. Did I make a mistake? You gotta love how that's my gut reaction. It doesn't factor, so there must be a mistake. 2x squared minus 7x plus 3, yes. 2x squared minus x, 4x squared minus 14x plus 6, 3x minus 9. So it's 15x and 6x squared. It's 2 is 6 is 5. Huh. Wow. Quadratic formula it is. So let me recopy that up here. All right. So x equals negative b. B is negative. Plus or minus the square root of b squared minus 4ac all over 2a. Oh, interesting. 6 plus or minus. So inside our crazy square root, we have 36 minus 5 times 2 is 10 times 4 is 40. We're going to get imaginary answers, which Alex may let you type in. So this is going to be negative 4. Square root of negative 4 is going to be 2i. And then everything here is divisible by 2. So we end up with 3 plus or minus I all over 2. And they might ask you to write it as 3 halves plus 1/2 I, 3 halves minus 1/2 I. But imaginary numbers are not restricted values. Restricted values have to be real. So there is no real solution. But if they allow for imaginary solutions, there's my imaginaries. All right. So coming up next, we got some word problems, some of which we have seen before.